Cool. Thank you very much, and I really appreciate being here. And I really appreciate your time. So I'm more than happy to answer any of your questions. I'm looking mostly at the Discord channel right now. My beard is awesome, and I'm not on a boat, but I wish I was. But just kind of, I didn't plan this out here. But you got to respect the beard here. So on more serious questions here, yeah, I guess what can I do to help answer? And so Markov, it really has very little mass actually in it, too. It's just multiplication. So if you can do multiplication, there's not even any division. So you just look at the probability of one letter falling after another letter falling after another letter there, and the more letters you have, the higher probability it usually is. Uh, Omen gets a little bit more complicated because they have this idea behind it called levels. But then you do away with some multiplication and you just do addition instead. So the final level of the password is summing all the levels across it. And the reason why you want to do that is because that's much faster than trying to do a more traditional Markov attack like you would see in John Ripper Markov mode. But there's a million different ways that you can do Markov. So I could talk to you all day about that if we want to just go ahead and get into that. Hashcat needs to update its Markov ability though, because it is probably the of all the algorithms the worst. But Hashcat's really fast, so it can get away with that. And I know you're just trying to be cheeky about that, but here's a just trying to give you an answer to it because I really enjoy it. Um, it would be nice. The challenge is that the guest generation port could probably be uh, extracted out, but figuring out what the kind of the rule to use is pretty much single threaded, unfortunately. So and that's really what takes all the time is it's just trying to figure out which of the rules is currently the most probable in order to run. And that's why it takes so much memory because it's basically building a probability queue of all different probabilities. And it's going through, it has a kind of this tree type of a format there. So long story short, I wish I could figure out how to do that. But where you're probably better off doing is instead of trying to generate all the guesses in probability order, you could actually just go ahead and generate guesses behind a different probability threshold. Say so all these guesses that are, higher probability than this level here. And in that case, you could absolutely go ahead and multi-thread it for GPU. So I've actually talked to some people about potentially getting this in a way so that you're not doing probability order, but you set that threshold and you could actually run this in the GPU. And it's the fact that GPUs have more memory now means you can start putting the base grammar inside GPU as well to help speed that up. So and I'm sorry, I should respond to the question here. Yeah. So the question was, could I run multiple PCFGs at once on multiple different GPUs? So the short answer is theoretically yes, but I could definitely use some help in actually coding that up with somebody who's smarter than I am. So does anyone else have any questions here, or I could just keep on rambling here too? One nice thing is being able to run this against the password list that you're currently cracking too, because it does do a pretty good job of stemming that and creating some really interesting input dictionaries for you to be able to use. So if you're kind of going ahead and doing kind of like a fingerprint attack, just trying to run it around again there. It can actually extract some really useful bits for that to keep on launching against people. So since I got like 9 minutes left here, unless someone else asks a question. Oh, ramble away. Okay, sounds good here. So the question is, or I guess what I could start talking about is where password crack PCFGs are kind of going in the future. One of my big goals is I really would like to be able to get incorporated into Hashcat. I started, brainstorming that quite a while ago. That's part of the reason also why it uses the compiled C version. I wrote it in the first place was because Hashcat for some reason does not actually run in Python because it's fast, I guess. So that is, ultimately the kind of the end goal for that effort there is to actually incorporate it into Hashcat uh, as a new cracking mode. The initial way I'm going to start looking at is actually having it run as a Adam calls it a slow guesser mode, which pretty much defines this exactly. So I want to be able to incorporate that as part of the Hashcat slow guessing modes that you can add in. Eventually, though, I would like to be able to start going ahead and seeing whether I can go ahead and parallelize the way it generates guesses and put it into the GPU to make it much faster. So there's other options too that potentially like you could basically do what really slows it down is generating all those rules. So in an older version, I had actually had the ability to go ahead and pre-compute all those rules and be able to save those to disks, so you could actually then completely parallelize it if you wanted to as well, because there's no rule generation. So that's another thing I could take a look back at there. The problem is that the rules are really fine-grained. So I almost want to go ahead and, in order to reduce the size of the rules on the disk, is to make the rules much kind of fatter, essentially. So each rule would correspond to more password guesses. But that's definitely an option that I'm kind of looking at as well, is to make this more feasible to be able to be used. So is there such a thing as a random PCFG rule? Are they human readable or, well, geek readable? The short answer is yes. So if you hit this kind of status output when you're running a PCFG, a cracking session, it'll kind of print out the text screen of what the current rule set looks like. And it looks a lot like a hashcat mask, actually. It just has a few extra different features onto it there. So you'll say something like the I use A for alpha string, but it was like A5, so it's generating like a 5-letter word, and they'll have a number next to it saying what the what the probability or ranking, I should say, of that 5-letter word is. It'll say like the 153rd most probable word, or number one, so it'd be the first most probable word. So that'd be like password. Um, so in that case, you can kind of read it, and then you can see what the capitalization mode is. So it'll say like the most common capitalization mode for this here, and it'll say like D2, and then it'll be like a number after that too, which is like the third most common 2-letter or 2-digit number. So you can kind of look at that and see what that rule is. Because the way that it happens there, you could absolutely go ahead and create a random rule for that, or you can kind of look at it and read what it's actually doing. And so you can go back to the grammar and say, okay, what is actually the 143rd, most probable word? And so, okay, so that's the word that it's using. And if the words have the same probability, they'll use just all of them there. So there might be like multiple different words that you only saw in the training set, let's say twice. So they'd all be used the same probability in that rule. It can also create, when talking about random passwords, some work I did in the past was creating what's called honey words. So these are passwords that look like human passwords, and PCFGs are really good for that. So instead of trying to create the most probable password, you do a random walk through the grammar. And that way, 1, 2, 3, 4, 5, 6 is still going to be very common. You're going to create that much more often than normal, but you also create some kind of random looking passwords too. And where this is really useful, for example, is if you're trying to set out a honeypot server and you want to do like a honeypot Active Directory or a controller, and you don't want to go ahead and manually create 1,000 different passwords for different fake users. That way you can go ahead and run that, and you create passwords that if you glance at it, it looks somewhat real. You're still seeing like the really common passwords. You might see the company names, the most common there, but you're still seeing some random other stuff as well. That's definitely some work, and improving upon that is I'd like to be able to create one that or a modification of that where it has a biased random walk, so that way that you can create passwords that look like they all came from the same user, but once again are somewhat different. So that's definitely an area that's kind of fun to play around with. What have you seen in terms of variance between, say, company 1 and company 2? So that's just a question that was asked. And the short answer is I really haven't seen that. And by that, I mean, I'm a researcher. This is a hobby for me. So almost every single dump that I've worked with has been, I would say, the public dumps. And while there definitely are company passwords that get pushed out there, especially if you look for like NTLM, but I'm a researcher, so you'd actually have to ask, someone like, CoreLogic about that there. So I'm not a really good person to answer, and that's why I'm always really interested in hearing these talks and talking to people who are actually doing this professionally, because they're able to provide me that information there. But pretty much all I have from that is secondhand. So we're getting to the end here. It looks like there's just a couple more minutes. So if anyone has any questions, feel free to ask them. Otherwise, I really do appreciate you coming in and viewing this talk. As I said, I'm available on Twitter at LakiW, LAKIW. And if you really want to get in touch with me, the best way to do it is submit an issue to the GitLab repo. That's probably the best way because I pretty much obsessively track that there. And I'll definitely try to get back to you. But this is something that I find is really fun, and I really do appreciate you taking an interest in this. Cool. Yep. And I'll be on Discord for the rest of the weekend too. So if anyone has any questions, feel free to pop in there too.